in Python, we were also looking at the pandas and the basics of NumPy. Okay, so the fundamentals were being discussed. Okay, just to keep in mind that we are supposed to get adjusted with the Pythonic way of programming. So that's the reason why we were looking at the NumPy and pandas in details. Okay, so in today's session, we will start with what is called as the visualization tool, data visualization tool. This is pretty much important because of the reason that we have to observe the data when required. So always we cannot say that the data that whichever what we observe is pretty much enough, right? So by looking at the table, we may not be able to get a clear idea about, right, what is happening. So because of that reason, we always have to use some of the plotting tools. So what could be the various plotting tools that are available here? We are going to see that. And in addition to that, we are also going to consider the various types of visualization. So first thing, what are the tools available? Second part, what are the various visualizations that we can have if we have a data set with us. So we are trying to answer two different parts of the question today. But we may not be able to go in pretty much detail like the pandas or the NumPy because of the time restriction. So today what we'll do, right, we'll not do the programming part. I will not type the codes. Whatever is present over there, I'll try to show you. Okay, so almost everything has been already it's a part of the code, right, where we can see the answers readily available. All right, so the first part is what are the two different tools that we are going to study. The first one is called as a Matplotlib. Second one is called as a Seaborn. So what are they? They are the libraries supported by Python, which can be used to visualize the data. Data visualization is necessary because if you have a great insight of what data you have, it becomes easy for you to say analyze it more, and it becomes easy for you to frame your problem, right? So because of that reason, we will be going for the data visualization. That is very much necessary. And the basic tool is Matplotlib, which is an older tool that supports almost any type of plot that we think, right? Everything that is important, everything, like it can be a pie chart, it can be a bar graph, it can be, right, stacked plots, etc. Many things, many types of plots are available, including the 2-dimensional, 3-dimensional data. We can go for the histograms, we can go for the box plots, many things, many types of what you call visualization is supported here, right? So what we do, we'll directly jump into that concept so that right, we can visualize and we can start the visualization. So that's the first thing. And the second part is called as the Seaborn, right? It's another visualization tool, but it is built up over the Matplotlib. So that's why we study the Matplotlib first, then we'll use the Seaborn in such a way that how some of the graphs that are already present in the Matplotlib is upgraded, right? So you can make sure that your visualization becomes more catchy, right? More vibrant colors, or something like standard definition into the high definition. How can you convert that kind of representation is what is very important here. That's why the Seaborn comes into picture. All right. So Matplotlib is a fundamental tool that's very widely used, widely accepted. It's very good, right? Some of the features are upgraded in the Seaborn so that we can even use that. So we'll have a small session on the Seaborn as well towards the end. Okay. So to start with, how do we install? So you can see here. So this is the installation part. You can see, I'm talking about the Anaconda prompt. So normally, the stack version of the Anaconda already has the installed Matplotlib. So you don't have to install it separately. That's obviously okay. But you can actually, if at all you find a version which does not have the Matplotlib, you can simply call this function conda. This is for updation, not installation. Sorry. If regularly we suggest people to keep upgrading. So if you want to upgrade, right, this is what is the suggested right method, right? You can simply conda update matplotlib, it will update. So next part is if you find somewhere some version which is not having the matplotlib, you can simply call it. So the name matplotlib comes into picture because they are trying to replicate the MATLAB version of the installation. Sorry, MATLAB version of the plotting. If you are comfortable with the programming the MATLAB, in MATLAB everything is considered as a matrix, and they are trying to use that feature for plotting as well. So here also they are trying to do the similar job. Only difference is MATLAB is paid version. You have to spend a lot of money if you want to use MATLAB, right? But this is free version. This is open source, right? So that's a very basic difference. So they try to replicate whatever features MATLAB is providing, right? They try to give that over here. So the name is also very similar, Matplotlib, right? It's a basically mat stands for matrix, then plot library. Okay, so you can check the version by using this particular command. You can see that when I was running the code, I got 3.5.1 as my version, right? The next thing is that you can see if you are using the Colab for the same purpose, right? You can do the same. You can check it in the same fashion. So just import matplotlib and check its version. Okay, so just do that. You can visualize that. Now, the most common way of importing matplotlib is by using a standard what do you call alias. It is MPL, right? So again, this is optional. You can even put your name, my name, anything over there, right? That works. So if you check that, this is how it looks like. It says that where it has been loaded. Then again, this is very common for you right now, right? Because if you just press a tab, it's going to display every function over there. So that's what has been shown here. Okay, so in this particular graph, you can see that MPL dot, press a tab button, it shows everything, every list, right? Then you can actually write this also, MPL question mark, and then run that particular cell. You will get a detail about what you are looking at. What is this? A complete short form of the help comes into picture. This is applicable. You already are familiar with this. I'm just repeating this. Now let's go to the important part. So the important part is where do you get help? Help is absolutely necessary. Okay, just look at this. I'll copy this and I'll paste this in our chat box so you can visit it right away. Also, you save this, make a bookmark this page. All right, so that I expect you to visit this regularly and check, right? Whenever you want help, you can go there. So this is a complete documentation page. So it contains how to install, right? Many resources. There is a cheat sheet present that's on the left side. You can download and you can keep it to any plot that you want to bring. All of a sudden, right? You are doing a code. You want to visualize something. You can simply bring it out. All right. So that's another useful sheet. It's called as a cheat sheet, right? It's provided over there. So others you can see here. Also, if at all any a new version comes, you will find that particular version's help over there. So you can see that, right? This was a snapshot that I took when I was creating this material. Then you can go ahead and you have another full list of tutorials. This is very highly important. Okay, let me copy that and let me paste that on our chat box. Okay, please open it. Please visit that as well and make it as a bookmark on your site. So you can see there is a lot of tutorials available. For example, what are the various plots that you can write? You can plot. What are the different plots that you can bring up from your data set? There is a complete list. If you start from the top and start learning one by one type of graphs over there, right? In order to reach the last type of graph, It may take months to get it. So many examples are this. It's a very wide library supporting almost each and every graph that you can think of. Okay, so please go through that and keep it as your reference. All right, then there is another important link, right? I'm going to paste that as well. So please use this. It's an example. Previous one was tutorial. This is an example. This is the set of examples. All right. So again, you can see various types of graphs that are supported over there, right? We can find it over here. So I have given 3 different resources for you to refer, and whenever you see, it's impossible to remember how to plot each and every type of graph, because if you go and check, maybe 1,000 types of graphs are there. So it's not suggested to remember everything, but you should know that, okay, there is something called as stacked bar chart. There is something called as a broken bar. There is something called as horizontal bar. Like this, the name you should be able to recall, and you should know how to use them. Okay, so let's move further. Let's look at what's called as the various types of the figures, right? Whenever we try to bring a figure over there, what are the various parameters, various components that Matplotlib uses in its figure? Because if I want to say change my y-axis to something, what is the y-axis according to Matplotlib? You should know what it calls. Is there any different name for my vertical axis? Is there a new name for my horizontal axis? Right, etc. Many parameters are there. Okay, so many components are there. We should be knowing that what component Matplotlib calls it, so that I can also tell that, okay, change this particular component, right? So that's the reason why we are doing something. We have to know the various parts of the figure, right? So whenever I ask something, whenever I ask Matplotlib to plot something for me, a screen comes up, right? So a space is created. That space is called as a figure, right? So the same word figure comes into picture, and I have to say that in this figure, make this modification. In this figure, bring this like this. Make this bold. Make this wide. Increase the font. Decrease the font. Increase the size of the figure, etc. Everything you need to do that. So remember, the name figure stands for the empty space which gets initially created when you say that I'm going to plot something. So that's the first terminology that we are going to use. It's called as a figure. In a figure, what are the various components that you might see? It's not true that always you'll see all these components which we are going to see now. Some of the components might come, some of the components might not come, right? In a general representation, but these are the various components you see on the top. What do you see on the top? On the top, I can see that it's called as the figure. Okay, so it's called as a title of the this thing. So I will write the title over there. It says that anatomy of a figure. That means it's the title of this particular graph that you're seeing. Okay, so this whole thing, the empty space which is getting created, the outermost boundary box, inside that whatever you plot, it's called as a figure. So plt dot figure, because plot is something which we are going to call now. Let me just check whether we called a PLT so far. I don't think so. Okay, don't worry. We'll come to that. So that whole space is figure. Then you see this is the title. So in this case, it says that anatomy of figure, but it says that on a circle we are writing that it's a title. Okay, so if you want to change over something over there, or if you want something to be written over there, you want to modify, means you have to call ax dot set title. So so what is ax? We'll come to that. Then, so you can see that there are 2 different types of plots that are being plotted over here. So on the right top corner, we can see a blue line, and then it says that blue signal. Then another line, another color given, orange signal. So you see, we are trying to create what is called as a legend. So I think you have used the same word legend if you are using the MATLAB as well. Okay, so if you are using the MATLAB, there also the same word is used, which is called as a legend. Then the important thing, right? The y-axis. You can see the vertical axis, right? So that axis has few important parameters. So what is the name of the vertical axis? It is y-axis itself. So there will be no confusion. So it is y-axis. Then there are several lines marked over there. So the thick mark is called as, or a larger mark is called as a major tick. So you can see that there's a major tick here. So this is major tick. Then if you go above, the number 3 is written near the major tick. It is called as a major tick label of the tick. Then you can see there is a minor tick because 3 and 4 are major ticks. So there is 3 here and there is 4 here. So between 3 and 4, I still have few dash written, which are smaller dash. So we call it as a minor tick. Okay. So along y-axis, these are the various points. You can give a name to the y-axis, that is y label. Right? Same term is used in MATLAB. Okay. So it's very much similar to that. That's why I told they try to copy everything from the MATLAB software. Okay. Then you can see we come to the horizontal axis, right? Its name is x-axis. X label is there. You want to give a name, whatever is along that axis, you can give a name. Then you can see the major tick, right? This is a major tick, there is a minor tick. And you can even give a label to that. Okay. So all together, you can see whatever comes inside this is called as the axis. Then the lines which are plotted, it's called as a SPIN, spine. Right? If you want to go with the markers like dot, circles, square, etc., you can see here it's written as a marker here. It's called as a marker. Marker plot. This is a line plot. Okay, and you can see, right, there are grids present over there. Right? Again, you can turn on the grids, you can turn off the grids, if right, depending upon your preference. So overall, what we have seen so far, it's called as the various components of a figure that we bring up in Matplotlib. So this is again very general concept, right? It's a very general and very simple, right? Most of them are familiar to if you are right already using a tool such as MATLAB. All right, let's go ahead. So this is how we bring the Matplotlib. You don't need everything in Matplotlib. So what you need the matplotlib.pyplot. So pyplot is something related to the Python, right? Plot. So we call it as a PLT. So PLT is the short form, the alias name, which you can use, right, whenever you want to call the functions under the pyplot. So that is very important. And one more important library that we need is the NumPy. So you can directly bring it as import NumPy as NP. So that's also fine with us. Now, one thing I'll bring at the initial phase, because this we might use several times at the next levels of discussion. So what we do, there are various types of coloring options available because, right, our intention is to bring the make the plots more colorful so that somebody who is going to see the plots that you have created, they should be happy after seeing that, right? So you want to bring more colors, vibrant colors, right? You can make it more attractive. So for that reason, they have created several what you call aesthetic styles of bringing the colors, something like a default coloring options. So how can you check what are the coloring options available for your figures? You just have to type plt.style.available, right? This command you try to enter. So as soon as you enter, you will see, right, a big list coming in the picture, right? Like 25, 30 different options available. Choose any one of them. How to choose, I'll come to that later. But this is how you check, because unless and until you know what is available, you cannot use it. So see, pick any one of them, right? And if I say classic, I'll just type like this, plt.style.use, right? I just say use classic. So whatever comes now onwards, you see the various plots that are coming up over here, right? They are of the style called as classic. So if you change this to any other, say, pattern like a Seaborn dark, you can. Okay, you will be able to find a different a different color scheme over. Okay, plot remains in whichever function you call, the same thing will be plotted. But what changes is the coloring scheme. Okay, so that's what is important. So you check everything, and maybe, right, you can decide which is the best one for you or which one you like most. You can set it. Okay, so the classic is the most standard one. So I'm starting with that. When required, I'll definitely change it. So the first thing is that, right, if I'm writing a command and I want to print something, in the sense I want to visualize something. So this is the command plt.plot. It draws the figure as and when required. So you see here, x-axis, I create linear space. What's the function linear space doing? Try to recall the fundamentals of Python, where we have discussed. Lean space is linear space. 0 to 10 will be divided into 100 equal pieces. That's why the 100 comes in picture. So I'm saying that between 0 to 10, cut that into 100 equal pieces. So we are actually getting 100 different locations, right? Starting from 0. Now you see, I'm saying that plt.plot. So the condition for plot is that I should say what I should plot along x-axis and what will come along the y-axis. So along x-axis, let me say I want to plot the x values. So what are the x values? You can see there, x values are linear space created between 0 to 10. So can you see the x-axis over here? So if you see here, in this plot, the x-axis is 0 to 10. But it's not just 0 to 10, not just 10 values. It contains 100 different values. Because x equal to, okay, so look at the command. I recreated a linear space. So because of that, we have this. And I'm saying that plot, PLT is the library which contains the plotting functions, pyplot. I'm calling in that plot x-axis x itself, and y-axis is np.sinx, because simple sin x is not going to work. I have to bring the calculation support from numpy. So the format is like this. I have to tell what is along x-axis here and what should be plotted along y-axis I should write. So every x plotted sin x. It's a dot 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 format. But since more dots you have, everything looks like a continuous string. Okay, so that's how you can use it. Now there is another version, right? I don't think any one of you are using this format. So if you can even run the Python on the command shell, right? Like a command prompt, right? You can even run over there. When you do that, you don't have any option to write or print your the window or the figure on the same page. You see here, this is on the same page. Just below the input, we are printing the output, correct? But you see here, this is again a snapshot which I took when I ran the Matplotlib on a system which consists of the Python running in the form of the command shell. So in case of this, you see, it actually opens up a new figure. So on the right side, you can see that there is a new figure that is coming in. Figure in the sense you can even drag drop everywhere. So that kind of representation is going to come if you are running it on a command shell, command prompt. Okay. All right. So the next point is, right, how can you make things to appear, right, just in the same line along your right output that is printed. So you just have to bring a magic command called as %matplotlib. After that, you can even write inline, right? When I say inline in the same page, without making sure that without showing that it has a different object, it actually gets displayed on the same page. So like this, whatever you see below, it's actually a inline display of the question that I asked. All right. Now you see, right? Figure is equal to plt dot figure. I'm actually creating a figure. A blank space is actually created. Then I'm saying that plt dot plot. X-axis is x itself. Y-axis is np dot sin x. But plot me using this format, in the sense dash 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 dash. So what is that dash dash? You can see the blue colored plot that you can see here. That is the first plot. The second plot is cos x, and it says a star. So use a star as the this particular type of graph which you are expecting. Whatever you are plotting second, that will be plotted in this particular fashion. Okay, so there are stars. So you can see stars written over here. This is star indicating that whatever you print, right, whatever you plot using that particular command will be plotted, right, as stars. Okay, at the same time, the top one says, whatever color you choose, no problem for me, but I want the answer in dash, 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 dash format. I don't want a continuous waveform. So this is the difference. Now you will have a question saying that, how do I change the color? Right? Because right now I can see two different colors. One look like a dark color, like black or blue, black or greenish color. And other one is a completely different color. And we can see that this is blue. So how do you change the color? We have two options. One, not specifying any of the colors. So in such case, default, whatever colors it can take, it will just add that. Okay, but when we go for what is called as discrete various colors over there, we'll be able to make sure that various colors come as per our specification. Anyway, I'm going to touch that. But before that, right, we will be going with the very important aspects first, because sometimes you may want to save the figure. If I don't tell how to save the figure, that's not useful to you. So I'll go with the saving options. So what is a plot? How do you specify the plot, etc.? What are the coloring options, etc.? We are looking at initial phases now. So this is a saving option. So how do you want to know that? What are the various file formats of images that are available so that you can save it? All right. So asking that as a question, you can see that. So this is the command. Line number 9 says that if you print like this, if you type this on your command window, right, where you type the programs and run that part of the code, it says that, okay, these are the various options available. Anyone you choose, you can save it. And then to save a particular figure, so this FIG says it's the name of the figure which you have created, dot save fig, and give the name followed by the format. So this is the name of my figure that I want to save, and this is the extension. So that extensions are directly available here. So see which one you want, and according to that, you can definitely save it. Okay, so as you can see, I already have saved something. Okay, but there is always a chance of what you call as duplication. Okay, so whenever you change that, also it's going to save it in the required format. Now the next option is that, right, I will try to I think when I have okay, when I ran this code, right, there was no error, but when I tried to run it again, there was a problem, saying that it was already existing, right? So that's right. Okay. Now, if already there is a figure by this name or something, I can check that. How to check that? Check this. So percentage ls, the name of the particular file which you are looking for, dot the extension. In this case, it was JPEG because I saved it in the JPEG format. So as you can see here, right? When I ran this code, it said that, okay, C users fresh is the location, and this was the date, right? On that date, I ran this part of the code. It says that so many bytes first fig.jpg. It is there. There is one file of this. So that's how you can find out whether it is there or not. Okay, any doubt so far? Next thing that we are going to discuss is how to, there is already an image saved in your computer. How do you load it and how do you see that? So in order to do that, we'll start with importing the display package, right? So that is ipython.display import image. So that's one of the standard what you call function that you can use to read an image. There are multiple other options. There are dedicated libraries only for what you call images. Okay, so right now we are not touching that. We'll just look at the very simple way of doing this. So image of first fig.jpg, because it's already been saved. I try to say that image, show me the image of that. So that means whichever this is the one which I had saved, right, on my computer. So that itself is getting displayed by just calling image function, image of, just mention that particular file's name, so that it becomes a image and it gets displayed. All right. So this is how you can do that. All right. Do we have any doubt? Is there any doubt? Right. So the next option is how to bring the multiple plots all together. So this is actually called as a subplot. I think you have used the subplot in the MATLAB interface. So I have just mentioned the same thing over here. So you can call plt.figure creates the figure. Then I'm saying that plt.subplot. If you remember the basics, I have to enter three different numbers over here. Something like x, y, z. So x is nothing but the number of rows in which you want to display the subplots. Now it says 2, 2, in the sense x is 2, y is 2. So you can see here, this particular graph, whatever graph we see here, it is actually arranged in the 2 cross 2 format. Why it became 2 cross 2? Because I said that give me a 2 cross 2 space, out of which in the first space, that is this one. Okay, in the first space, so you just have to plot plt.plot x comma np dot exponential. So exponential is being displayed here. Next one, you see plt dot subplot, right? 2, 2, 2. So it's like 2 comma 2 comma 2. So I am trying to plot np dot cos x. So where is this 2 location? 2 location is here. So left side is 1, then 2, then the below one, that is 3. So if you see 2 to 3, that is e to the power minus x. Okay, so then we have a subplot 2 to 4. There we are plotting the sin x. So that is over here. So starting from the top left, that is 2 to 1, then 2 to 2, then below the first one, that is 2 to 3, then 2 to 4. So 2 comma 2 means there will be totally how many elements? 4 elements. That's why you go from 1, 2, 3, 4 as the third element. Okay, so that's what is the easiest way of creating and using the subplot, and that is pretty much similar to that of the what you call as the MATLAB style. Now we'll go for another version. This is actually the standard version in Python. So if you don't want to go with the MATLAB version of bringing up the subplots, you can even go for the another method that is called as an object-oriented interface. Right? So this is how it's going to look like. I first have to say that plt.subplots. I'm creating a subplot that actually creates figures and axes. Figure in the sense is the size. Axis means totally, right? You may use 2 axes, 3 axes, etc. So that's what you are trying to bring into picture. Now, so what we'll try to do, we already have created this. Now we have the axis also with us, we have the figure with us. Now you have to create what is called as an object. So you will say that ax axis of 0, 0, that means it is corresponding to the first one. Plot me this function. So similarly, you see ax of 1, 0, plot me this one. 1, 0, 1, 0 means it is right, a row is increased. First column, second row, that is this particular graph. Is that okay? So this is a particular graph. Then we have 0, 1. Ax 0, 1 means this graph. Okay, and the last part is 1, 1, x, comma. So that will be NP of sin x. So you can see this is the sin x plot. So we have created a 2 cross 2, again very similar to the previous case, but what we have used here is this approach is called as object-oriented interfacing, right? So in order to create a plot, we can even use this kind of representation. So if you're already comfortable with the subplotting techniques by using the previously shown method, please go ahead with that. There is no restriction saying that this is the only method you need to use. Anything you want, you can. Okay, so that's the initial parts of our graphs. So in the next part, we'll move into what is called as a simple line plots. So in order to create that, something like y equal to fx. If you want to bring that, if you want to bring such graph, you have to create the figure first, that is plt.figure, because plt is already been brought into your computer whenever we started the session, right? So plt.figure and plt.axis. So both of them will be created and they'll be put up into FIG and AX. Okay, so that will be done first. Once it is done, you can see the result is just an empty space. So then we have, just check this. So I'll say that PLT plot, in that I want the grid. So it actually creates that particular size of the figure. And when I say grid, we can see the lines coming into the picture. Horizontal and vertical lines equally spaced, right? Wherever you have the major tick, right, at that location, we can see the grids being created. Okay, now you see I changed the style. So in this case, you see AX and figure have been created in the pretty much same way, but I'm saying that x dot plot. So along those axes which you have created, I want this machine to plot this particular function. What is that? X versus, so I can show you here. So this is X versus sine X. So X is along the X axis and the Y axis will be the sign of that X. So that's why you get a graph like this. Look at a color change, right? This has a darker boundary, right? So it has a darker boundary, right? So here you don't have that. It's slightly different. Okay, may not be we may not observe a major difference right now, but yes, as you change this plot style, right? plt.style.use, the colors that are used going to be they keep changing. Okay, that's about this plot. Let's move ahead. So the next part is about how to bring multiple plots on the same figure. So simply call it again and again. You don't have to do anything. Like you see here, I called a sin x first. Then I also called the plt.plot.x comma np.cos x. So both sine and cos are plotted on the same graph. So you don't have to do anything if you want that as your target. Okay, very straightforward. Then we move ahead and we'll look at what are the various color line, what are the various colors that we can define based on the colors, right, which we want to do. So how to specify that, we will see. Right. So the first option is to specify the colors. So what are the options that I have to specify the colors? This is how. So first thing, look at the comment that is written. You can specify the color by the name, like blue, black, etc. You can type, it will be. Then you can even write a short code for that, like RGB, CYMK, etc. That's also very standard. You can use that. G for green. That's why you can see a green graph coming into picture in my in the visualization. Then a grayscale value can also be entered 0 to 1. So I can see that there is a gray colored graph whose value is saying that it is 0.75. Okay, so that 0 means it's a darker version, in the sense black color. So 1 means it is a bright color. In the middle, you can give any number so that that particular color will be collected and displayed over here in the graph. So the fourth version is a hexa code. So 00 to FF is a standard code which you can enter and you can get the color plot. All right, then you can also enter the HTML color names. Okay, so there will be a list of color names which we call as a standard, and they are standard in terms of the HTML color code version. So that's why if you want Vistas, okay, if you want say put the colors in this way, right? You can write the specific color code that needs to be extracted from the HTML code. Okay, so most of the time we will be going with the first one or the second one, and if you are going with the grayscale, we'll go with the third one. But yes, I have to tell that there are other methods like this. So the last three we may not use. The first three will be used many times. Okay, that is about how to change the color. Next, you see how to change the line style. You see, each line is different. First one is just dot, 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 dot. Second one is dash, dot, dash, dot, dash. Third one is again larger dash. Fourth one is a complete dash, etc. You can see this kind of representation is possible, but you just have to specify. Okay, so the solid one, that is the solid line you see here. Okay, then you have the dashed one, that is dash, 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 like that. Then you have dash dot. Okay, and at last we have. Okay, so just check that and let me know if you have any doubt. Okay, let me know if you have any doubt. All right, now you see both the line styles and the color code. Both we can specify in a single command. I don't have to write it separately. Now you see here. So this is a combined format saying that dash is my solid line, G for a green color. So you can see that in the result over here, I actually got a solid green color line. So the next one, I want dash dash and the color is cyan. Okay, so that's actually the second graph. Then dash dot with a black color. So B cannot be used for a black color because blue, it is already assigned to blue. So for black, just remember it is K. Other colors are actually starting from their name itself, like blue is B, green is G, red is R. They're very standard. Only for black, it is K. Okay, then you can see the other option is like plot. I just say that it's a colon and R for red, that is for sure. So the colon actually stands for the dotted line. So that is what you see as your fourth line on this particular graph. Okay. Then I can actually put some limit on the axis. X lim stand for what is the minimum and maximum values of X you want to see on the graph. What is the minimum and maximum values of Y axis in the graph? You can specify that using Y lim. All right, so just see here, X lim says -2 to +12. So -2 is what you can see on the leftmost side of the graph, and 12 is what you see on the rightmost. Similarly, along the Y axis, right, it says -2.75 to -2, so 2 plus 2.5. So -2.5 is somewhere here, and +2.5 is somewhere here. Okay, so that is how we try to apply the limits on X and Y axis as per our requirement. So in order to specify the axis, right, limits, you don't have to go with the two different commands like we did earlier. You can simply enter a single statement like this. So you see here, plt.plot, I said that this is what I want to plot. And after plotting that, now I say that make all the axis, put all the values of axis according to this number. You just have to make a list there. Okay, so just look at that. You create a list, -1.5 or 15. So that means starting from -1.5 till 15, I want along the x-axis. That's what you can see over there in the plot. Similarly, I say specify. You see, this is the format: x min, x max, y min, y max. So x min, x max, is what is this? You can see here, X min, X max. This is Y min. Y min is minus 2.5. All the way it should go till 3.5. So minus 2.5 is the bottommost horizontal line's position, and 3.5 is the topmost position of that. Okay. So let me know if you have any doubt. The next part, what if I don't know what is the limit I should put, and if I want to say that put me the tight axis, in the sense make this axis very as tight as possible. If that is my intention, so this is what is required. Simply say that plt dot axis and tight. So tight in the sense tightly bounding box will be created around your graph. Now you see on the wherever your point, wherever the plot reaches the maximum point, right? There itself you have the upper right boundary on that. Same thing happens with the lower boundary, left side boundary and the right side boundary. Again, they are very tightly bounding your graph. Okay, so that's what is a tight stand for. Then you can even go for an equal options. So when you see plot axis equal, so whatever is the total length that you have from 0 to 10, vertically also it's there will be 10 units. You see, this is minus 3 to plus 3, right? So including that, so the axis will look pretty much equal to. Okay, so that's what is equal. So the equal aspect ratio will be used. That's what is the meaning. Then you see, what if I want to give the names, right? So naming is also very important. So just say, if you want to give something called title, plt dot title, then give the title that comes like this. This is a tan hyperbolic function. It's a tan function. Then I say that X label, right? Inside the inverted commas, I can write that this is X. So I can see X is being printed on the horizontal axis at the bottom. Similarly, right, PLT Y label, right, tan H, you can see that the tan H gets printed over there. So like this, you can give the names to your axis. And then when I have multiple axes, I can use what is called as a legend. So what's the use of this legend? Legend actually tells what colored graph is what. Right? So for that, you have one particular condition saying that there has to be a label present for that. In the sense, I just said that previously, I said that plot plt dot plot x comma this, and I might have given a color. That's all. But if you want to use a legend, remember, people miss this always. They say that, okay, I have written everything correctly, but I'm not getting a legend. That is because you have not given a label. Because label is the one which legend uses to show there. You see that in the result, you see dot, it says that cos 2x. How it came to know that is cos 2x? Because I give a label. So whatever you are plotting here, right, this graph is a cos 2x graph. Whatever you are plotting here, right, that is a tan hyperbolic. You see, that's how the function. All right. So as soon as you have to call this plt dot legend, this puts the name at the appropriate positions. Okay, so that is what is the use of legend. All right, let me know if you have any doubt. Now, so what are the equivalent commands that I'm supposed to use if I'm going with the object-oriented plot? What do you mean by object-oriented plot? Look at an example. Previously, we used one of the graph by using the object-oriented method. Okay, right? So see, this is the method. Right? So if you are using this, you can use the following list of functions. All right, so I'll just show the functions again. So you see, instead of using plt.x label, you just have to say ax.set x label, ax.set y label, ax.set x limit, set y limit, and set the title, etc. You can use if you want. If you are going with the other method, you just have to use it. All right, so let's go with one of few more examples that might come in our whole discussion about to use the what is called as object oriented interface. All right, so those who prefer to do that, yes, this is how you do that. So you just have to create an axis saying that in my plot, that is plt dot axis. Plt is an alias of our whole function, so I'm just bringing that. Now I have to say that in this axis includes both x and y axis, plot x comma a function. In this case, cos 2.5x is the function that I'm calling here. So this is what is the plot. Okay. But later on, I should say that set something on this graph. You already have plotted the graph, but make these changes in that. What is that? X limit is -2 to 12. Right? Y limit is -2.5 to 4. After that, look at X label is X, Y label is cos X, right? You can even type the complex or very lengthy string also, okay, right? That will be printed. So Y label is cos X. Just give a title to that. All right. So what happened here? The plt.axis, the axis will be brought over there. It plots a function. X is set between -12 to +12. Y is set between -2.5 to +6, and it will simply give the title which you want to be shown over there. So the same thing has been shown. Let's move further. Another option is that you can print something, right, that you get in the form of a data set. You can print that using what is called as a scatter plot, right? So scatter plot will scatter X versus Y on a graph. If they are in an order, you will see the order itself, like this case. It's not a random scatter plot. It's a proper scatter plot. Okay. So just see that the NP linear space I'm trying to create 0 to 10 with 25 spaces. If you make this 100, they'll come very close and your plot may look like a continuous plot. So don't do that. Make it a lesser number like 10, right? Or 20 or something like that. I create my y-axis, that is np.cos x. I say that plt.scatter x comma y, whatever is x versus y. Just say that marker with this particular fashion. So that D stands for diamond here. If you look carefully, every dot that you see on this graph is in the diamond shape. So that shaping is supported by this. I'll come to what are the various options you have for the marker shapes and marker types. Okay, we'll be coming to that at a later stage, but just understand that this is another type of graph. That is what is called as the scatter plot. Now, the another very important graph that is widely used, right, is actually a scatter plot, but we'll not call it as a scatter. It is called as, right, the circular. The size of a point can be controlled by a circle. So, right, the size varying the scatter plot, you can call it something like that, right? So this is how you do that. I generate X and Y. np.random.random. You are very familiar with that now. So I'll generate different colors also. There are 50 points I'm trying to plot. So for each of the 50 points, I'm trying to create 50 different sizes. Right? So size is equal to 500 into np.random.rand. I'll call it in this way. Okay. So different sizes are also created in a random fashion. So colors and sizes should vary. Right? So what I'll do, I say that plot dot y comma x, and I have to say c equal to colors. That means colors which you have created. S is should be the sizes. Alpha is equal to 0.4. What happens? What is this alpha? Alpha is actually the transparency level. Okay, whichever that data has been plotted here, you can see this graph, right? It's actually, you can see it is transparent. Whenever a data point is overlapping on other, you can see that. That's what is transparency. By making changes in this, you can, right? You can definitely, you can visualize the transparency getting changed. Okay, so 0 means not transparent, 1 means completely transparent. So any value within that, you can even keep it, right, to make that. Then there are various color maps. You can see here there is a what is called, I have used what is called as a C map. C map in the sense what kind of colors that you can get, you can plot right over here. So that is actually indicated by CM. The command is CM for color map. If you enter plt.cm then tab, it will give a complete list. What are the various color maps are available. So just change this VIRIDIS by the first one, that is accent, so that everything gets changed to the accent. So like that, you see various options are there. Just try by yourself. and you'll be able to understand which color map is very useful. You can just remember that, so that every time you just use it. Okay, so that's what is the significance of this. Then we'll move on to the next type of the plots. It's called as a error bar, right? Error bar, in the sense, normally it is used to show how much error that may be present in a given given point. Now you see, everywhere you have a point that is marked, but on both the sides you have a straight line drawn and a horizontal line drawn at the top. So this actually says that the central value, wherever you see a thick point, is the point which is the measured point. But if you are using a sensor for measuring the points, definitely there will be some error associated with that. So how do you represent that error? You will you just have to use what is called as a error bar. So every point has certain errors associated with that. That's what we can see here. So we just have to create the linear space. So np dot lin space 0 to 1195. There is no other reason. Sorry, you can simply create that. 15 numbers I created between 0 to 120, 190. Then I'll say that there is an error of say 0.5. So what I do, I create a y using this function, and also I add a random number to that into the error. Okay, so just look at that. Then in the next this thing, I'm actually calling a function called error bar. Okay, so what happens with the error bar? Error bar creates that error error bar plot, but I need to actually pass what is the error that is present along your along every point. So I have kept it as a constant here, that is ERR. ERR is 0.5, right? And it actually plots that. Then there is a RD is the format, R for red color, D for diamond. So red diamond is what I'm asking. You can change this to any other shapes you want. Okay, so we'll come to the change of shapes there. Again, I have another, I can make it more attractive by doing something like this. So first few lines are same, right? First few parameters are same, plt dot error bar, x comma y error and format. Okay, that is fine. Then you see the color is specified as color red. Then echo, E color, that's actually the light gray, right? And we say line width, that is 6. And I can also specify, the cap size. So do you require a cap size? You can write that, otherwise you can simply name it. So using this, you can convert your previous graph into this graph. Okay, so let me know if you have any doubt on this. We'll move on to the next type of the graph. It is called as the counter plot. It's also called as a density plot. And let's say we create actually a function, right? The function actually takes in two values, x and y. So you see here, x is a float, y is a float, and returns a float value. This function has been created because for each set of x and y values, we need to create a third dimension. Okay, so the third dimension which we are going to bring now will be of the following type. All right, so that means we'll be able to visualize in a third dimension is going to be presented over there, right? And that will be used as a plotting function. All right, so that means, so this is what is going to happen now. All right, so x and y, well, let's create that. X equal to np linear space 0 to 5, 20 different values, right? And y is equal to, again, linear space between 0 to 4, 30 different values. So x and y values are randomly created, you can see, right? They are not random, sorry, linearly separated. Fine. Now, so it's actually, you have to imagine that there are some x values and some other y values. Okay, x equal to say 0, 0 0.1, 0 0.2, 0 0.3, like that. Y is also 0 0.05, 0 0.0, 0 0.1, 0 0.15, 0 0.2, etc. So if you connect everything, it's look like your graph sheet, right? That's what is called as a mesh grid. you create, I'm saying that get me the mesh grid of these X and Y values, put it into the capital X and capital Y. Now you see, I'm calling Z is equal to my function. Why it is Z equal to my function of X, Y? Both capital X and capital Y will be passed, and you are returning a complex, right? A complicated function, not complex. So NP cos X to the power 10, because into star means it is power. So cos X to the power 10 minus sine of 20x into Y, 20 plus xy, into sine of something. So some random number, randomly I try to create these things. Okay, so and I bring the contour plot over here. Where do you see this kind of graphs practically? Anybody wants to answer that? Where do you find this? So have you seen this kind of graphs somewhere? Think about that, and if you have answered, please put it in chat. I'll wait for say 30 seconds. If you have seen this somewhere, right? These kind of graphs. Yes, that's right, Sanat. On maps. To tell that in my map, what are the regions they are of the same height, correct? Specifically Google Map. Go to the Google Map in the right map view and go to a location which contains a lot of mountains, right? Mountains have different heights, because since we are looking at the map from the top, it's not possible to say that okay, the shape of the mountain is like this. If you have a mountain like this, so this particular region is of same height, this is of same height, this is of same height. Every part of that mountain, different part of the mountain has different heights. So to specify that, they use a counter plot. A line is drawn and there will be written something like 800 meters. In the sense, that line, wherever you see that particular counter, right, it is of height 800 meters from sea level. If you go, there may be another line inside this 800 meters saying that 950 meters, because it is much, the height of that counter is much, right, more compared to the previous height, like that. So you can even have dotted here. So the idea is in this particular case, what you see here, the thick line means it is positive height. You have dotted lines indicating that that height is negative. So where any value comes below 0, it actually automatically plots dot 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 dot. Now we have a question saying that how do I bring the numbers over there? I want to see that number like 800, like, right? Any number that you want to see, I want to see that. How can you bring it, right? So yes, before that, I'll tell you how to change the color first. Okay, so larger values of the colors, you may get red color, right? Lesser values of the height, you may get a gray color. So that's actually possible by just bringing a color map. Just bring a C map equal to RDGY. RD for red, GY for gray. Red and gray color mix I can use this. So you already know how to check the various color maps are possible, right? In your machine. Yes, you can use that and you can keep changing and you can get beautiful graphs, all right? Beautiful color combinations. So I leave that part to you. Find out what are the various C maps available, color maps, and try this. Then I'll move further. Now you see, there is another way that right, I can bring a color bar into picture. So right, instead of just looking something like this, I can make the colors to vary. You can see the brightmost color is yellow, right, which actually represents the least point. Numbers are being less. As the height increases, consider this to be a mountain, right? Many mountains you can see, right? As the height increases, the red color increases. So the most red that you see here means it is the highest point. Is it that? No, it's a reverse, as you can see on the y-axis. Sorry, there's the details are available on the rightmost side. You can see here. What do you see here? So minus 0.9 is red color. So red means it is it's actually the depth. Okay, and yellow means it is plus, so indicating that the height, actual height, the positive height. So yellow points are the highest points and the red points are the least points in this. Okay, so you can bring the color maps into picture. So in this case, again, I brought a different color map called autumn, right? You can change it to different sea map and you can see different colors coming into picture. All right. And I can even bring the grids over there if required. Okay, and I can make the colors changing from a very smooth way. You see here the colors are actually changing drastically. Yellow was there, suddenly it changes to a different color, suddenly changes to red, suddenly changes a variation of red. So this some of us may not like this kind of changes. I want smoothly changing. You see here, colors are changing very smoothly. So that is possible because of a different function called IM show. In a sense, I am saying that don't show me the graph as it is. Don't show me like this. Okay, show me the graph as an image. Okay, images are expected to have a smooth change in the colors. So that's what is happening here. Because of that, I'm getting something like this. Okay, fine. So look at the commands by yourself, right? Because it will take definitely some time. Also, you may have to refer to the three different materials I shared at the beginning, the links I had shared, right? So just go through them and refer more details about this. Because inside this particular graph, I have 100 options. So mostly I will never be able to touch all the 100 types. So only when you go and you search by yourself, you'll come to know about that. Okay, so let's move further. Now you see, this is how you bring the numbers over there. Like height is 800 meters, 850 meters, 1000 meters, etc. You can bring it into picture like this. So you see, it actually gives a color code, right, for each of the heights. Plus, actually draws the lines and it is going to mention what is that corresponding to. You see here, I told, right, the dotted lines are actually negative numbers. So this is minus 0.8, this is minus 0.4, this is 0. Around the pink color, whatever line you see, that is a zeroth line. In the sense, that's the normal height. Then the height actually increases 0.4, 0.8, etc. Okay, even you have a height equal to 1. So height equal to 1, what color it is? You can see the color map that is present on the rightmost side. So, right? So according to the heights, the colors have been coded here. So you can see that. All right, very important and very useful if you are dealing with some geographical data or something. All right, the next very important type of graphs is called as histograms. So histograms are something like you have a data, right? For a range, you plot something. This is something like, let's say we create random numbers of, right, within 1000 and hist of my data. So you can see here, right, a random numbers are which are created here, right? There are 1000 random numbers that are being created. So you can see that all of them are being plotted over here. Okay, it is between -3 to +3. And you can see the highest numbers are actually around, say, 0 to 1. It actually has a value approximately 220 or something. So what are the options I have? This is my data set. I have a data. I'm saying that this is the bar I am plotting. I can actually make the changes. How many bins you want? Bins means how many boxes you want. So in this case, you see, it's a default, right? Whatever is the default value, it is actually showing them, right? So you can see the 100, 1000 which have been created, right? So this is how it looks like. Okay, so you see 216 is the highest one, 212 before that. So the central one is 216, before that 212, then before that 162, then before that 64. And coming to the central one, 216 once again. Right side of that you have 201, that is 201, then 84, then 23, then 11. So whatever data set that you have created, it's actually plotting that itself. Okay, so that's the plot. Now, what are the options I have? Again, if you refer the documentation, right, the link which I have provided, you may see 100 options related to this. Correct? So I want you to go there and look at the exact details. But something which basically what I can tell here is that changing the number of bins. So you see here, mostly here, how many bins were there? Starting from -a, this is one rectangular box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So default it is 10, let's see. 10 is the default number. But if you want to increase, you can use bins equal to 40. Now you count from -3 to +3, there are 40 different small boxes. So as you increase the number of boxes, the width becomes reduced. That's the first thing you observe. Then I can even bring the alpha into picture. What is alpha? Already we have used as a transparency. If I use 0.4, this becomes more transparent. Okay, so it's 0.7, 0.8, and when it becomes 1, it is non-transparent. Right? You can even tell what color you want. Color in the sense, what is the color of the box? That is steel blue. Do you want a edge color? In this case, if you see around every box, there is a color that is red. So I mentioned that over here. Okay, so this is another way, right? A small modification that might happen. Then coming to another very important version of the histogram, right? We have to specify what is called as a hist type you have to specify what is called as hist type, and you have to tell that this is a step fill. So step filled in a sense, everything looks like a step for you. Currently it is this, then goes to next step, then next step. You don't see a separate box or a container for each of the rectangular representation. So this is what is called as a step fill. So each of the graph here is a step fill. Then how I created three different three different graphs? That's just because I created three different numbers. Okay, x1, x2, x3. Then for all the three, I created a dictionary saying that this is the type, this is the alpha, and I need 40 bins for each of them. That's what has been put up into a different variable called KWRs. Different arguments. Just give any name, that doesn't matter. So then I say plot hist x1 and use those variables which we have created. Right, so use that as the features which you want to plot. Now you see we have three different graphs and three different colors are automatically given for three different colors. Okay, three different graphs. Okay, so very important. Looks very nice if you have something like this whenever you present something to to somebody who is going to look at your work. All right, so that's another version of the histogram. Then the histogram can be brought up in 2-dimension, multi-dimensional histogram. Now you see, I cannot, when I have X and Y, both are varying and I want to measure something, I have to have a third dimension. So 3D visualization is what is expected, but if that 3D visualization is not so easy, not possible, then we can use what is called as a 2-dimensional histogram. Now the height, instead of visualizing the height of the third variable, you look at that as a color. So darker color, more height it is. Lesser color, right? It means, or a bright light color means lower height. Okay, so let's bring it into that picture. So what you see here, right? We have the X along X-axis, variable, Y-axis along Y-axis. So how you created that? We created like this, X comma Y equal to np dot random. We created a multivariate normal. So if you remember, in random number generation under the NumPy, we had discussed these kind of topics. Okay, so that actually talks about how can you generate random numbers of different types. So here we are using a normal distribution, that is a multivariable random distribution. So you have to pass a mean value, covariance value, and you have to tell how many numbers you want to create. So that is 6,000 numbers are created with this mean and this covariance. So it creates that. So X and Y are available. I'm simply saying that give me a histogram. I need 25 bins, and the difference is that this is a histogram 2D. So whenever you use this, it creates a 2-dimensional histogram. So I just have to give an option saying that show me this, show me the color bar, that is on the right hand side. Whatever you see, it's on the right side. I also have mentioned what is my color map. So again, go back to the color map, visualize what are the options available, put anyone over here so that you can understand what color map is what. So this DUGN actually is a color map which contains the colors, right, starting from the white color to the green color. So we have the same range coming here. Lowest is 0, highest is 120. Lowest is a white color and the highest is a green color, darkest green color. You can see two darkest regions over there. So they are the 2 points which actually corresponds to the highest value of your z-axis. Z-axis is tallest at those 2 points. But anyway, this is also very similar to the map version. You are looking from top. So this height is not visible when you look from top. You just see the darkest color over. Okay, so this is what is called as two-dimensional histogram. All right. So again, once you get this material, go through this in detail so that you understand, right, how the code is written over here. Then another option is that you see here all the histogram, the points are marked as a square or a rectangle. You can change it to hexagon if you want, because even sometimes you see this may look like more attractive, correct? So you can do that. So just option is that plt.hex bin. I just have to say that get me the hexagonal bins, not the normal bins. Then almost all other colors will remain same. Okay, so you see here, this is the color now. So lowest is green color, highest is the red color. So there are two highest points again on this graph. Okay, other slightly lesser colors means red color. Then the moderate color is yellow. Wherever you see yellow, you can consider that to be the midpoint. If you consider this to be a big mountain, the halfway points or halfway heights are actually yellow colors. All right, so like that you can understand. So then we'll move to the different types of legends. So few of the major types of graphs I could cover. Few more will come at a later stage. Right. So how to bring the legend? Already you know that I have to use what is called as labels. Label equal to sine, label equal to cosine is what I use. Then I just say that get me the legend. Ax.legend means it brings up the legend over here. Normally what happens, legend whenever it is called, it will come to a position. Normally it is on the top right corner. But there is an option that you can change it. So just look at this. So if at all I want to change the position, right? How do I do that? So what should I do so that I can change the position? So position of this can be changed. Just look at these are the positions. Positions can be specified by using a string. It's called as a location string. You can say best, upper right, upper left, lower right, left, center, etc. Can be done. Otherwise, you can even enter a code over there starting from 0 to 10. Any number between 0 and 10, both are inclusive. You can specify that this is where I want. If you do that, then also it's going to work. So see here, this is an example of how to put the legend to the lower left. See, it came to the lower left. At the center. So you see, this came at the center. And I say n col equal to 2. In the sense, represent that in 2 columns. Don't write one below the other. Write it in the 2 columns. First column is the sign. Wherever the dash sign is written, consider that as the first column. Then dot cosine is written. That's the second column. Number of columns equal to 2. Okay, you can definitely specify that. Right, that's what is this. Then you have another option called as, right, using it as a what you call fancy box. Fancy box in the sense, see here, I have no box here. Okay, so here I use what is called as a frame. Frame in the sense where whatever legend has been printed, to that you get a frame. It's not a fancy box, but now you see it is a fancy box. Sine and cosine are actually included inside a fancy box, and you have, right, a frame alpha for that. In the sense, you have a 50% transparency for that, and shadow is also there. You can see below that you have below and the right side you have a shadow. Many options are there. Okay, so in the legend you write legend dot question mark, legend question mark, and run that part of the cell. You get complete details. Okay, I want you to go through this, or you please go through the material which I gave links initially, right? Just go through that, and there you understand the complete details of that. Then we go to the multiple subplots, right? How do you go into the multiple subplots, right? So multiple subplots in the sense, I have a bigger plot. I may want a small graph inside that at a specified location. So what I can do, I can create 2 axes now, because one for the bigger one axis for the smaller one. So the bigger one is normal. That is what you see, the outermost one. The complete big box, what you see, that's the AX1. AX2, I have to specify the ratios. In the sense, starting from the bottommost 0, 0, how much you need to move to the right? That is X. X is 0.5. Look at this. Somewhere at the center, it is 0.5. That's why. And how much height you should travel? That is also 0.5. See, this is X, Y. So X is 0.5, height is 0.5. I reach the beginning of my second axis. The second graph, which is a smaller graph. Then it actually says what should be the length, what should be the height of your inner box. So it says 0.2. If you say this is 0.5, this point is 0.5, this is 0.6, this is 0.7. So 0.2 has been added. At the same time, to this point, how much height I should cover so that I can finish my inner box, that is also written 0.2. In the sense, if this height is 0.5, 0.6, 0.7. Okay, so inner box actually specified in terms of the relative distances, like 0.5, 50%, 50%, 0.2, 20%, and 20%. Okay, so like that we are specified. So the complete details are actually entered here, right? Later on, please go through that and please understand. And how do you get two different graphs, one below the other? One option is that you can directly go to what is called as a subplot, and you can do that. That's one option. I just wanted to tell you a different method to do that. How can you use two different axes to create that? Okay, so the two different axes have been created here. This is the axis 1. Oh, no, sorry. So this is the axis 1, like just now we understood, right? Same way we have created two axes here. Okay, and then we actually called the plot function, right? So that this kind of plots can also be, right, can be created. Then how the subplots are created, right? When I have multiple subplots, right? How do you access them? So you see here, this subplot is 4, 2, 4 rows, 2 columns. I can see that 2 columns are there. So row 1, row 2, row 3, row 4. And how many columns are there? 2 columns. So 4, 2 means this is how the arrangement will be. If you write 2, 4, this will be transposed. There will be 2 rows and 4 columns. So that's the transposed version of this. Okay, but now what I do, I'm trying to tell you can actually access each of these subplots in a loop. Okay, in a loop you can do that. So that's what was my intention. So for loop in a range 1 to 9, that is 1 to 8, 4, 2, I. Now I varies from 1, 2, 3, 4, 5, 6, 7, 8. So how they are printed, I'm trying to print the same thing. 4, 2, I, you print at the center of the each of the subplot. That's what is my point here. What happens here? You see 4 to 1 is printed. That means this is how you access. If you want to access this particular subplot, you should enter, right, plt.plot 4, 2, 1, right? In the sense subplot 4, 2, 1, this is what is happening. Okay, plt.subplot 4, 2, 2, if you enter, that will print something in this particular graph, right? So it is always a row wise. You are filling it row wise, 1, 2, then 3, 4, then below that, right, 5, 6, 7, 8, and so on. All right, very important, right? This is required. All right, so this is also the same thing done in a different way. So I'll slightly move further forward, right? How do you create the various number of this thing? So again, this is an example which actually creates 5 rows and 4 columns. Okay, 5 rows and 4 columns. Each one of them actually, right, share x equal to column, in the sense columns are same. You see, the values are given only at the bottom line. So that means it is shared by all of them. Similarly, for each of the graph, the y-axis is common. So y values are written only on the leftmost graph. Bottommost graph has x values, leftmost axis has the y value. So indicating that this is how, right? I'm saying that all the graphs, all the subgraphs share rows and columns. How do you specify? You have to say share x and share y. So when you specify that, you get a curve like this. Otherwise, you see, every time, every graph will get its x-axis, its y. So it's left to you what type of graph you want to use. But This is the other option. Okay. All right. Then, yeah. So this is actually called as what you call the object-oriented technique to access this. Same thing what we have written earlier. You can do it something like this. Okay. This is the other method which uses what you call as the object-oriented technique. Right. So let's go further. Now, okay. This is the other important one. I know that I have a specified space available for me to graph. What if I want the subgraphs to be plotted, but they are of different sizes, not everything same. So far, wherever you consider a plot, right, everything created the same size of graph, right? Every subplot is a same size. What if you want to change this? What if you want to go for a different type? So this is how you have to specify, right? Now you see, I create a 4x4 subspace. So there is actually space for 4 columns and 4 rows. Totally how much? 16 graphs are possible. Straightforward. Understand that, right? So 16 different spaces are being created. Now I'm saying that give me a subplot with the grids 0. 0 means initially whatever you write is a row number 0, and all the columns up to 3. 3 is excluded. So I have 4 columns 0, 1, 2, 3. So row number 0 starting from 0, 1 and 2. So first 3 graphs should be clubbed together. What is that? That is your first graph. That is this graph. Whatever you see here, right? This is the graph which I'm saying that 0th row and first 3 columns 0, 1, 2. 3 is excluded because if I write colon 3, 3 is not included. 0 to 3 minus 1. So that is 2. So this first line is what? The first line actually creates this particular graph. Okay, inside that you can plot anything, but I'm just saying that how to create that space. So once we know that how to create that space, definitely I can plot something more. Okay, the next one you see. Plot, there's a subplot grid. Everything means all the rows, comma, this is the third column. Correct? I need all the rows of third column. Where is the third column? That is the last one. So see, this is the one which we are talking about by using the line number 3 of 57th cell. It says all the rows, third column. So third column, all the rows means all the 4 rows are clubbed to get a single space where you can plot something. Look at the next one. Okay, subplot. It's a grid. It says 1 to all, starting from 1 till everything that you have in the 0th column. Sorry, in the 0th column. Yeah. So first one, that is 0th one, first one. So exclude the 0th one, starting from first one, all in the sense till the end. How many you have? You have till 3. 1, 2, 3, row number 1, 2, 3 of the first, in the sense 0th column. So that means we are talking about this particular graph now. This particular subgraph is the one which actually, right, does this job. All right, very similarly, let's move to the next line and let's just check what we are plotting here. Subplot 1, 2, 3, 1, 2, 3. 1, 2, 3 means 1 and 2, 1 and 2, because 3 is excluded. 1 to 2, row number 1 to 2, row number 1 to 2 means, right, row number 0, exclude 1 and 2. In that column also 1 and 2. So that means we are talking about the center square, right, central square area which we have saved for a subplot. Okay, and look at the last one. It is the third row and first and the second column, because 3 will be excluded because of the statement 1 and 2. So third row 0, 1, 2, 3, third row and 1 and 2. Third row 1 and 2 means these two. Okay, I hope that's fine. So like this you can create. Use this and create as and when you require, because you may not require the same space for each and every subplot. So normally this, I expect people to use this rather than going for all equal subplots. Do something like this, make it more attractive. Okay, all right. Then now we come to what is called as the various styles of sheets. So the styles of sheets in the sense, you can see here, So various styles of sheets can be defined. So this is the default one. You can see here, parameters are Python default. This is the default graph that you get. Okay. But if you use what is called as a style called as 538, name is given like that. We have no idea why people give a name like 538. But still, you see, when you change your style, Python plotting style to this is how the same plot looks like. I'm not saying that, I'm not actually, I'm not changing the colors. I'm not saying anything. I'm simply calling my function, my plot. It plots like this. Same thing. You see, I'm changing my style to different one. See, automatically it plots like this. Next one, BMH. So most of the styles you are able to see here, but there are many more styles available. Please explore that when you have time. Okay. So my plots, it changes to this. Then again, you see dark background. The name of the style is dark background. This is how it looks like. And there is what is called as only a gray scale. Only gray colors will be used. Darkest one is the black color. Brightest one is white color. Anything between that will come into picture. So you see, this is how we can change the styles. Changing the style and plotting means this is what happens. Same plot will look like different way, right? Using different color schemes, or we call it as a style of plot. Okay, so that should be clear by now, I guess. So let's move further. Next, we have what is called as three-dimensional plots. Okay, for some extent, it actually supports 3D plots as well. So only thing is that I just have to mention that I have to import mplot3d because two-dimensional plots are default, but I have to say that I need a third dimension to be added. So for which I have to use MPL toolkits and import 3, right? Import this. Then anyway, create a figure out of that. But I need to say that projection equal to 3D. Three-dimensional view is what I want. I'm mentioning that by using this command. Okay, so it simply creates a three-dimensional space where you can plot. Now you see, this is how I create a plot. So I'm creating three different values. I call it as X line, Y line, Z line. And also I'm trying to plot some points on the spaces. So I'm calling it as X data, Y data, Z data. So if you see, it's actually created by sine, cos, linear space, random numbers, etc. Right? Something we did randomly and we created that. But you see, it's called as a scatter 3D. You created your axis like this. So this is the three-dimensional axis. But when you say that x dot scatter 3D, my X data, Y data, Z data, C is equal to C for color. Use color for using this, and color map is blues. This is what I see. And if you want a line, you can call it as plot 3D. Plot 3D is a normal plot, but in a three-dimensional space. X line, Y line, Z line, and use a gray color for that. This is what is the part. Now you see, we have two graphs here. One is just a line, which is a helical line that you see. That is in gray color. That is actually is this statement. Plot 3D. Plot means it's a continuous plot. And the second one is a scattered plot. Scattered. So how the points are scattered, you are seeing that. So you can see that is what is a scattered plot. Okay, not the line, the dot, what you see there. That's actually the plot. So I try to club two of them together, right? Whichever you want, you can use as per your requirement. All right. Also, we have what is called as a counter plot. Three-dimensional counter plot is visible, right? It's possible to create that. So create your mesh grid. All these things you are already aware of. So what we have done here, we created a function which creates a sine of square root of x square plus y square. Sine of root of x square plus y square is my function. I'm creating that using this function. My function is that. Then I'm saying that, okay, I created x, y, and z by using these lines of codes. Already we have used that in the previous section, so it should be clear to you. Now, coming to the plotting part, I have to call a function called count to 3D. I have to pass all the three variables x, y, z. Right? So other parameters are corresponding to the counter 3D. You can see that this is how it looks like. So it's a three-dimensional counter plot. So every counter that you have the same height. You can see many counters are there in this particular graph, right? Now, you can change the view by setting the degrees at which you want to visualize. 65 degree, right? It was originally, by default it is 45, but you can make it change as 65, means you come more closer. Okay, and 25 means it can be rotated like this, right? So one is you can move close to this and the object can be rotated in this way. So how much rotation is required? That is what is called as this 25. All right. So in technical terms, it's actually elevation, and the azimuth. So those two parameters you can change. I just changed this. This was a default one. When you change the 65 to 25, 65, 25, new values, this looks like this. Now you understand that's how you are changing the view. And the next option is changing the colors, right? Modifying that, etc. Right? I can call it as a wireframe. You can see this graph is completely different compared to the previous one. Previous one was all circles. Now you see it looks like a mesh for us, right? That's why it's called as a wireframe. You can use it to get a graph like this. Change the color as you require. Red, green, blue, anything you give, it comes over. Okay, then you can also give a different color scheme for that. So you see color map, I changed to magma, right? So this is what happens. Only color scheme has been changed. Okay, so till here, whatever we were discussing, right, was belonging to the fundamental types of graphs that are supported, and they're the basic graph under the Matplotlib. Now we'll go for what is called as a Seaborn, right? So I want to give a differentiation between the Matplotlib and Seaborn. So let's look at how the graphs are going to look like in general when we consider the Matplotlib. So this is Matplotlib, right? Graph. A general graph which contains 4 different things. So look at the quality, right? And whatever you are able to understand, just look at this. Okay. Now doing the same thing in Seaborn will bring it like this. Okay, so you see, this is actually more attractive. That's why I told that Seaborn is built up over the properties of Matplotlib. So you, if you use a Matplotlib, right, and you plot it, that may not look very nice because it's a slightly older version, right? And the Seaborn is the advanced version. Recently, this came into business, so you can see that this is going to look like more advanced whenever you use it. Right, so this is just an example for that. Now, what are the other options available? You can do something like this, right? You can bring a graph and you can bring another graph in front of it and you can make visualization. So that's another feature of what you call as the Seaborn. Okay, and the next option is what is called as a KDE plot. This is kernel density estimation plot. You are actually plotting the probability density functions, PDF. If you have studied the probability statistics in engineering mathematics, right, you will have gone through what is called as a calculation of probability density function, PDF. So this is a PDF plot. Okay, so how to get a PDF plot? You just have to use a function called KDE plot, and you have to pass the column over here because it's a column right now passing because we are using the pandas data frame. Okay, so since it is a data frame, there are 2 columns X and Y. I'm actually passing the right columns over there. 2 columns are there. Both columns you are actually plotting the PDF probability density function. All right, then there is a possibility you can bring both the KDE, right, and the dist plots. So you can see here there are two plots in each of the categories. One column there is the histogram as well as KDE, right, continuous as well as the discrete. For the second one also, you see here the blue colored continuous line and blue colored histogram plots. Everything can be plotted together. Again, this is another feature. Okay, let's go proceed further. You can get what is called as a KDE plot, something very similar to our counter plots. I can bring the KDE plot into picture, right? You have to use a function called KDE plot. Just tell which data is x-axis, which data is y-axis. So x-axis over here, horizontal, y-axis over here. Corresponding to that, we are converting that into the counters and we are plotting it over here. Okay, very important. Again, this is a part of the Seaborn. Now you see the advanced plots under Seaborn. Very, very interesting and very useful. right? I can actually visualize a scatter plot, that is what is inside the square, as well as each x, how the x varies. What is the, either you can bring the KDE over there or the histogram over there, doesn't matter. You see on the top, I get a histogram of x-axis. On the y-axis, I get a histogram of that y variable plus a histogram, plus a scatter plot. So this is not possible using the basic versions of basic tools or basic libraries. The Matplotlib will not support this. So you have to go for Seaborn if you want to use. Okay, let me go ahead. See the whatever is inside this, right? I can change it. I can change it to the what do you call this? This is a two-dimensional C map and two-dimensional plot, right? So I can bring it that into picture. This is called as a histogram of hexagonal bins. I'm bringing that with the normal histograms on the X and Y axis. So this is what is called as a joint map. Remember this term, you may have to use it. Okay, joint map. Right. Then there is what is called as a pair plot, right? Because it's actually a most important and most general way to visualize the various columns and various columns of your data set. How they are related to each other, we can visualize in a single shot by using what is called as a pair plot. Okay. But what we do now in order to in order to visualize this in a very clear fashion, we don't have any data set with us. We bring a data set. So the Seaborn actually has a data set called Iris data set. It actually talks about what are the various flower types that you can classify based on the petal length, sepal length, and petal width, sepal width. So based on these four characteristics of flowers, how can you classify the flowers into various classes? So there is a data set. So we bring the data set and you can see the data set looks something like this. Okay, sepal length equal to this, sepal width, petal width, and these are the various species that you have. Now you see, I simply call the pair plot of this data and I say according to the species, give me a height of equal to 2, right? Even if you don't write this, doesn't matter, you get a different colors of and different size of your plot. That's fine. Now you see, what are the columns? The first, sorry, what are the rows? Row names are sepal length, then the second row is sepal width, next you have petal length, then the petal width, because those are the four features. Whatever you see vertically, they are the features of the data, right? Same names come along the sepal length, sepal width, petal width, along a row, indicating that again I am measuring the same thing along the vertical axis. Okay, and it says that the blue color is for this particular species called as setosa. Okay, then we have two more colors for the two other classes of data that we have. Now you see, what do you understand from this? It's called, this graph is called as a pair graph. Okay, pair plot. Now you see, right, the petal length. So sorry, this is the sepal length. The first column corresponds to sepal length. I am changing the sepal width. Or okay, sepal length versus sepal length. If I plot, this is how it looks like. Okay, sepal length has a mid value somewhere here, right? So sepal length of the second class, that is the second color, is somewhere here. Okay, is distributed in that way, as well as the third color distributed in that way. I'm able to visualize everything in a single shot. At the same time, now let me change it. If the sepal length is considered, sepal length versus sepal width is the second graph. That is this graph which I'm pointing out. You see, this is how they are varying. They are related to each other in this way. Okay, then this is sepal length. Again, I'm considering the petal length. Sepal versus petal lengths are having a distribution like this. So last one, sepal length versus petal width are going to be distributed in this way. So whenever you are considering the same parameter, sepal length versus sepal length, that will be a PD, probability distribution function. Okay, it becomes a distribution function. For others like sepal width, and the petal length, petal width versus sepal length, you get a dot over there. What is that plot called? It is a XY plot. All right. Fine. So same thing happens here. So if you have 4 different columns present in the data, right, we get the PDF plot over here, right, along the diagonals. All diagonals will be the same, right, because it is the, you see here, the third one, it is a petal length along the rows, and if I come down, that's also petal length. That's why wherever they are same, you get this kind of. Okay, others are the XY plots or the scatter plots. So anywhere you have others, you can see that this is how it is. For a class number 1, petal length is over here. Petal lengths are of this particular size. Okay, whereas if you want to look at the sepal width, they will be having this kind of distribution. So a feature versus other feature, I can actually measure. I can actually compare by using what is called as a pair plot. Okay, so even if it is not very clear to you, don't worry, right? When we go ahead, when we do some, when we try to solve some practical things, right? When we do, and when we get a lot of time to discuss over there, this will be more clear to you. Okay, then let me bring another type of graph that is actually called as it's called as phase histograms. Right, so let's try to bring in another data set called tips data set. This tips data set is something like at what day, at what time, a particular server in a hotel got how much amount of the tip. What's the amount of tip that he got? So this is something related to that, right? So you can see here in this particular graph, we are seeing that lunch and dinner. The first graph is for lunch, second graph is for dinner. So I can understand that the tip you got by male, right, is more compared to the female. So you can actually make a comparison like that. Okay. At the same time, I can see that in during lunch, mostly the females, right, are getting more compared to the male. Or it's like that. So you see, you are able to compare, right, and get something and plot it in a different way. These kind of graphs are also possible. That's what is called as the faceted histograms. So subset of your data set can also be used for visualization. All right, so similar things can be brought into another way. This is called as a categorical plot. It's a cat plot, right? I can see that, right, Thursday, right? You can see that the total bill is varying from, this is the minimum value, this is the maximum value by male. So for female, it actually ranges from here to here, right? Corresponding values you can do. Same thing, Friday, it's like this, right? Saturday, different value. Sunday, different value. So we can observe that, right? Maybe the amount spent on Saturday by female is more compared to more compared to males. Okay, so again, you can have a different views on the data set if you use various types of the plots. So that is what is very important. I expect you to work on this further. So the same plot which we have used earlier, it's called as a joint plot, right? I can see a distribution that's the hexagonally binned graph at the center. That's a 2D graph. And I can also see the histograms of X and Y data on the top and on the right. Okay, already we have used this. I can even, as I told, I can even bring the KDEs over there. So you can see the KDE, the kernel density estimations are being plotted along with the histograms. Okay, so it's again a joint plot. I just have to give various specifications inside this so that we can modify what I require. All right. Okay. So with that, we have come to the end of the session.